Let me show you something. Every single panel in that facade, hundreds of them, each of a different size and shape, was generated automatically. No copy, no paste, no manual adjustment. The architect set up a system, a set of rules, and the software drew every single piece. That system was built in Grasshopper 3D. And right now, on day 1 of this course, you have zero experience with Grasshopper. By the end of today's video, you're going to understand the core logic that makes all of that possible. And you're going to build your very first parametric machine. I am Ajit Kumar and this is your complete Zero to Expert Grasshopper course. 60 days, 8 phases, real architectural projects. Let's go. Before we touch the software, I want to give you a mental model that is going to carry you through this entire 60-day course. Think of Rhino, the 3D software we are running Grasshopper inside of, like a drawing table. When you use Rhino directly, you draw shapes by hand manually. You click points, type coordinates, move things manually. It's precise, it's great. But every time you want to make some changes, you do it by hand manually. Grasshopper is different. Grasshopper is a programming machine that sits next to your drawing table. Instead of drawing shapes by hand, you describe how shapes should be drawn. You set up a rules and the machine draws everything for you automatically. Here is a key idea. Say this out loud with me. In Grasshopper, I am not drawing. I am describing how things should be drawn. The moment that clicks in your brain, everything else makes sense.
Now, how does Grasshopper work? Think of a factory assembly line. Raw materials come in on the left side, they go through the series of machines, each machine does one specific job. The output of machine A becomes the input of machine B. Finished products come out on the right side. Similarly, in Grasshopper, the raw materials are numbers, points, and curves, your inputs. The machines are called components. Each does one thing. The wires connect components and carry data from one to the next. The finished product is 3D geometry that appears in Rhino. Data always flows left to right. Left side input and right side output. That's the whole model. Everything in Grasshopper, even the most advanced definition you'll build on day 60 follows this exact structure.
Okay, Rhino is open. You can see the viewport, that's our 3D working space with a grid on the floor. Now, to open Grasshopper, it's very simple. Find the command bar at the top. That's a white input box where you can type Rhino commands. Click in it. Type the word Grasshopper, then press enter. And there it is, the Grasshopper editor opens. Now, let me orient you. At the top, you have the tab menu. This is where all components are organized by category. Math components are under math, curve components under curve, and so on. The big gray area is the canvas. This is your workspace. Everything you build goes here. And behind the Grasshopper window or to the side if you arrange them, you see the Rhino viewport. That's where your 3D geometry appears. The canvas and the viewport are linked in real time. Let me move the Grasshopper window so you can see both. Good. Now let's place our first component. To place any component in the Grasshopper, you double click on the empty gray canvas. Try it. Type construct point. You see it in the drop down. Click on it to place it. That's your first component. Let me zoom in so you can see it clearly. Now look at it carefully. On the left side, you can see 3 small tabs, X, Y, and Z. These are the inputs, the 3 numbers this component needs to create a point in 3D space. On the right side, there's one tab labeled PT, that's the output. It's the actual 3D point the component creates once it has X, Y, and Z. Right now, the component is using default values, all 0, so there's a point sitting at the origin. To control the X, Y, and Z inputs, we use number sliders. A number slider is exactly what it sounds like, a handle you can drag to change the number value interactively. Double click the canvas again, type number slider, place it. Now do this 2 more times. We need 3 sliders in total, one for X, one for Y, one for Z. Great. 3 sliders stacked vertically. Now we need to connect them to the construct point component.
This is where the wires comes in. See that small circle on the right side of the top slider? That's the output. Hover over it, your cursor changes to a crosshair. Click on that circle and hold the mouse button down, don't release yet. Release. The wire snaps into place. The first slider is now connected to X. Now do the same thing, connect the second slider's output to the Y input of construct point, and the third slider to the Z input. Perfect, now let's look at Rhino. See that small red cross in the Rhino viewport? That is your point. It's sitting at the origin right now. X0, Y0, Z0, because all sliders are at 0. Watch what happens when I drag a X coordinate slider. The point moves along the X-axis. You're looking at parametric design in action. The slider is controlling the geometry. Change the rule, the geometry updates. Now it moves along Y. Now it moves upon Z. You just built a parametric machine. I know it's just a point, but you have just understood the core concept that everything else in this course builds on. One more component before we do the exercise. We are going to add a panel. Think of it like a display screen that shows you exactly what data is flowing through any point in your system. Double click on canvas, type panel. Place it to the right of the construct point component. Connect the PT output of a construct point to the panel input. Now the panel shows the exact coordinates of your point. Drag the sliders, watch the number updates in real time. This is how you debug and understand your own Grasshopper definitions. The panel is your best friend. When something goes wrong in Grasshopper and things will go wrong, you connect the panel and read exactly what data is flowing through. The data always tells you the answer. Alright, let's do the practice exercise. I want you to use the 3 sliders to position the point at these 3 specific locations and check the panel each time to confirm. Position 1. X1, Y0, Z0. The point should be 1 unit to the right of the origin. Position 2. X0, Y1, Z0. Position 3. X0.5, Y0.5, Z0.5. Now the point flows diagonally above the origin. After each position, confirm the panel shows the exact numbers. If it doesn't match, your wires might be crossed. Double check which slider connects to which input. Your homework for today, and this is the challenge task, is to explore negative coordinates. Right click on any number slider and select Edit. In the panel that opens, change the minimum value to -20 and the maximum to 20. Now your slider can go negative. When X is negative, which direction does the point move? When Y is negative, what happens? Try to position the point at exactly X -10, Y -10 and Z 10. Use the panel to confirm. That's day 1. You open Grasshopper, you place your first component, you connected sliders, you move geometry with data, and you understood why this is called parametric design. Tomorrow, day 2, we are going to connect 2 points and build our first line. Then we'll make a circle with a controllable radius. The factory gets the secondary machine. If this video helped you, hit subscribe. This entire 60-day course is completely free and the full playlist is linked below. Every day builds on the last, so don't skip ahead. Drop your challenge coordinates in the comments. I read every single one. See you in the next one.